afternoon, guys. I've been thinking a lot about how to improve my lessons for you in this last week of instruction prior to the AP test, and there's very few people coming to our Google Meets, and so and I think it would be helpful for you guys to see more problems just worked out. So I'm going to do more. I'm going to do this one that is assigned to you as well. So if you want to follow along, or maybe, again, pause the video and try part A right now and see if you can do it, and then catch up with the video and see how you did. And this is another style of problem that you might see. So you'll either see a Diffy cue like this, or you'll see a Diffy cue with the slope field. So there's two options that you might see. So anyway, I think these are more difficult than the slope field problems, because usually slope field problems have the dy dx, which just makes more sense. But here we're doing dw dt. So we're going to do this landfill problem. All right, which is your first problem on this homework assignment. So at the beginning of 2010, a landfill contained 1,400 tons of solid waste. So that is giving us our initial condition, right? At t equals 0, 1,400 tons. Okay, the increasing function W models the total amount of solid waste. Planners estimate that W will satisfy the differential equation this for the next 20 years. W is measured in tons and T is measured in years from 2010. Okay, use the line tangent to the graph at t equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months. So, and then they're telling us, okay, 3 months is 1/4 of a year, which we knew, but that was nice that they did that. Okay, so let's go ahead and do part A. Use the line tangent. So again, tangent line, we need a point and a slope. So our point here is t equals 0, and at t equals 0, we've got 1,400 tons. So that's our point. It's not x and y, it's t and w. Okay, and our slope is dw dt. So all we have to do is plug in 1,400 for w. And this was a no calculator question, so we've got 1,100 divided by 25. And we can leave it like that, even though it's kind of weird, but I don't want to do that, so I'm just going to leave it. And now we're going to write our equation. So y here is w, so w minus 1,400 is equal to 1,100 divided by 25, which probably goes in evenly, but I'm too lazy. T minus 0, right? Okay, and now we're going to use that to approximate t at 1/4. So I'm going to kind of make this a little bit better here. 1,125 t, and I'm going to add that 1,400 over. Okay, now we're going to do w. Can you see all that? Oh, good. 1/4 is equal to 1,100 divided by 25 times 1/4 plus 1,400. And so that's 100. So that we just get the 11 plus 1,400. So this 4 times 25 is 100, and then the zeros cross out. So we get 1,411. And what would our units be here? The amount of solid waste, so that's tons. All right, part B. Find the second derivative in terms of w. Use this to determine whether we are an overestimate or an underestimate. All right, so we're just going to take the derivative. I'm going to do something to the derivative here. I'm just going to distribute. So I get W over 25 minus 300 over 25. Okay, and okay, so we take the derivative and we get 1/25 times dw dt, and this goes away. Okay. But they wanted it, go back to the question, in terms of w. So we have to take this, which is dw dt, and plug it back in. Okay, so we get 1/25 times, then we're going to replace dw dt, right? The derivative of w is dw dt, just like when you take the derivative of y, you get dy dx, right? So that's how we got that. And now we're just going to replace it. So it's in terms of w. Okay? So we did that. Okay, now we get to plug in 1400 for w. So d squared w dt squared at t equals 0, like what do we get? So it's 1/25 times 1400, right? 1400 minus 300 over 25. So again, we get a positive number here. So, and we don't need to, you don't need to evaluate 25 times 25, which we know it's 625, but we don't even need to do it. We can leave it like this, and we can just say that's greater than 0, right? Oh, you can't see that. Sorry, I'm a little bit crooked here. So we can just say it's greater than 0. So that means, therefore, W of t is concave up because dt squared is greater than 0, which means that if we're concave up, then our tangent line approximation lies below, so it's an underestimate. So the tangent line approximation is an under approximation. Okay. All right. We did part A and B, and now we get to do C. So C is asking for, I'm a little bit crooked, find the particular solution. So now this is where we do our separation of variables and anti-derive. So I'm going to do another page. I'm going to flip this page over, and we'll do it right here. So we're going to start with dw dt. And our first step, that's separation of variables, and that gives us points on the test, even if we do nothing else, you guys. So we're going to multiply both sides by dt, get the dt's on the right, and we want the w's on the left. So we're going to divide there by w minus 300. So the dt's go away, and that goes away. So we get 1 over w minus 300. dw on one side and 1/25 dt on the other side. Okay, so we did that, check. Now we're going to integrate. Okay, here we go. Integrate both sides. This is the ln, right? ln of w minus 300, because that is a 1, right? You can think of it as a 1, is equal to 1/25 t, right, plus c. Okay, so we did that. Now what do? Okay, because we have an ln, we want to get rid of that ln first before we plug in our initial condition. So if we want to get rid of an ln, absolutely, we're going to E it. E it. All right, here we go. So we're going to E this side and we're going to E this side. Remember to put this in parentheses. That's important. All right, so then this goes away. And we've got W minus 300. We're going to leave those absolute values in there for the time being. And then we're going to distribute this. So remember, if we're adding in an exponent, that means multiplication, right? So it's e to the t over 25 times e to the c. And remember what we do with e to the c? Let a equal e to the c. Okay, so that's going to get replaced. And now we've got our nice I would leave it like that. That's our general solution. Okay, now we're going to plug in 0, 1400. So our initial condition. All right, so 1400 minus 300 is equal to a, e to the, oh, I love that, e to the 0. What's e to the 0? Yeah, you got it. So a is equal to 1100. And we didn't notice, we did not use the absolute value. It was already positive. That's important, right? Okay, so we plugged that in, solved for a. We did that. Now we're going to plug a back in and solve for w. Okay, so we can drop this absolute value and add the 300 over. So w of t is 1100 e to t over 25 plus 300. And certainly we do get, if we plug in 0, we do get 1400. So there's our answer, our specific, our particular, sorry, I should use the same words as they do, particular solution. And you're done.